Professor Patrick Haggard. He's a professor of cognitive neuroscience at the University College London and a former fellow of the Institute in 2016 and 2020. So thank you so much for joining us, Professor Haggard, and please go ahead.
Well, thank you very much for this nice introduction, and it's a great pleasure to be here as a one-month fellow. Thank you very much for the opportunity. I'm going to share my screen, and I'm going to talk about an experiment which has been highly influential in my own field. I'm hoping that you can see my screen, so you should be able to see the title of the talk. So it's common in science to think about experiments. Those are, if you like, the key markers of scientific progress. But it's relatively rare that we think about them in a wide contextual way. So I want to talk about perhaps the dominant experiment in my own research field and try to provide an embedded intellectual history of it, which I think helps to understand the whole field and this experiment in particular. I'll explain the experiment in due course. But first, I want to introduce a little bit where we're coming from. So I'm an experimental psychologist and a cognitive neuroscientist. And experimental psychology sits at the conjunction of two traditions. The questions come from philosophy, and the methods for answering them come from science, and particularly from physiology. So if we look at the projects of Enlightenment philosophy, there was a lot of consideration about what is human nature and how does the human mind work. And here's a beautiful quote from Immanuel Kant. There are three absolutely irreducible faculties of the mind, namely knowledge, feeling, and desire. So we associate that with Kant, but in fact it was formulated by a very interesting philosopher, Moses Mendelssohn, many years earlier. And we can think of all the things that human minds do as being either cognitions and perceptions, knowledge, or feeling, affect and emotion. And this third one is very interesting because it's exactly the space where I work, but it's largely been forgotten and ignored in history of psychology. Kant uses the word desire. We also have the old Latin word conation, which has basically fallen out of use now, which means trying. And this refers to the particular set of mental faculties associated with will, with trying, with aiming to achieve a goal, and with the way that the mind can choose an action to get a desired goal. So our minds don't just understand the world, our minds also change the world by making things happen according to our desires. So that is classical Enlightenment philosophy on the one hand. And on the other hand, we have the astonishing 19th century tradition of understanding the brain and understanding the nervous system. And the key person here was Hermann von Helmholtz, who was perhaps the first person to realize that neural activities take measurable time. It takes time for the electrical activities in our neurons to propagate along those neurons, and it therefore takes time to think. This, in a way, is the founding proposition of all experimental psychology. If we look at the history of studying the mind experimentally, it almost always involves time measurement. And no more so than in the work of Wilhelm Wundt, who was Helmholtz's pupil, who set up the first ever psychological laboratory, who made psychology and experimental science. And Wundt realized that the time of subjective experiences, the time at which we see things, feel things, want things, intend things, and do things, can be measured using objective methods. And this led to a long history in psychology of what is called mental chronometry, which is understanding things by asking questions about when. So let's just put that together with the idea that there are three completely fundamental things that minds do. And the mental chronometry approach had fantastic results in understanding perception, modest results in understanding affect and emotion, and absolutely no progress whatsoever in understanding conation, volition, desire, trying, intention, all of the aspects of mind that initiate action. And the reason is quite interesting. So the 19th century project of measuring time to study mind largely depended on a single instrument called the hip chronoscope, which was a beautiful piece of instrumentation engineering made originally by a Swiss watchmaker. And it allowed measurements of when people perceived events to start and stop, when people perceived intervals to start and stop. And this kind of approach to measuring mental time requires some event which starts the clock and then another event to stop it. And in the case of ideas like free will or volition or autonomy, or the idea that our actions are somehow our own and up to us, this start signal is really problematic, because what is the start of my intention? What is the germ of my decision to raise my hand or to make a particular action or to use a particular word? Where do our actions come from? The starting point of our actions is internal, not readily measured by this kind of clock, and maybe it's even unknowable. So that, I think, is the reason why the 19th century, despite the rich philosophical tradition of thinking about will, made no experimental progress really on this topic whatsoever. Despite a number of attempts to study higher thought using the methods of psychology, nobody ever got as far as will. And the next interesting historical marker is a study in 1965 by Kornhuber and Dieker, who were interested in the idea that some of our actions are up to us, they're voluntary, we decide to make them for ourselves, they're not based on any particular stimulus or input. And they simply recorded what happened in the brain when people make such spontaneous self-generated actions. And although you can't study these actions by manipulating any input, because by definition, the input is up to the subject to decide for themselves, you can measure a reliable neural correlate. So these are EEG recordings from electrodes placed over the frontal regions of the scalp. And you can see that if you align these recordings on the moment at which a person makes a voluntary action, you can see there's a systematic, rather ramp-like increase in neural activity measured by an electrode on the scalp just above the frontal lobes, which precedes the voluntary action. So the voluntary action has some cause, and maybe this is the cause of it, this so-called readiness potential. So Kornhuber and Dieker, I think, were excited that they thought they had found the basis of free will. I think that was perhaps over-optimistic. I think that's not really what the readiness potential is, but it's some kind of precursor to our voluntary actions. And the Libet experiment is at one level relatively simple. So here is the report, or rather wordy paper in the journal Brain in 1983, published by Benjamin Libet, who interestingly, when he published this paper, was already at what might be considered retirement age. So it was a very mature paper in his own thought journey. The time of the conscious intention to act in relation to the onset of cerebral activity or readiness potential. And notice the subtitle, Unconscious Initiation of a Freely Voluntary Act. So what did Libet actually do? Well, it's relatively simple. He combined mental chronometry, the idea of measuring when people have particular subjective experiences, with EEG recording, which is the recording of physiological events in the brain using electrodes on the scalp. He asked people to make a voluntary action whenever they feel like it. We might ask people, when you're ready, press this button. It's up to you when you do it. And while you're thinking about that and then eventually pressing the button, you're watching a clock hand go round. The clock hand rotates continuously. And the clock is simply there for you to say when you first decided to press the button, or in Libet's words, when you first felt the urge to move. So the clock hand provides some way that we can represent the time of a subjective experience of will or intention, which Libet called the W judgment. And we can do that relative to the actual objective events of pressing the button and the objective events of the increase in the readiness potential. And the result is relatively simple. So here is the voltage recorded from electrodes over the frontal lobes. And here is the time, with 0 being the moment that movement actually begins. For example, the moment that the button goes down. And you can see that the readiness potential begins often a second prior to the movement, but people report what Libet called the W judgment, what I would prefer to call the moment of conscious intention, just 206 milliseconds before they actually move. So the result is that there's this big gap indicated by my gray arrow here, when your brain appears to be preparing the action because the readiness potential is beginning to rise up towards this peak that occurs at the moment when you actually press the button. But you only become aware that you're going to press the button here where the red line is. So this gap in terms of time is often more than a second, which from the brain's point of view is a very long time indeed. So what this means is that our intuition that our conscious thought is the cause of our voluntary action can't possibly be right, because conscious thoughts because causes precede their consequences. And if our conscious thought was the cause of our action, you would expect conscious thought to come first and then brain activity second. In fact, it's the other way around: brain activity first, conscious intention second. If you're a neuroscientist, that's not surprising, but if you are, if you like, a member of society, if you share the intuitions that our consciousness and our thinking is related to what we do, and perhaps makes us responsible for what we do, it's a bit surprising. So I'm going to see where my animations have got to. The intuition that conscious thought causes actions looks like a dualistic mistake. And the true origin of voluntary actions instead lies in unconscious brain activity. So that seems to me like what a neuroscientist would inevitably conclude from this experiment. But Libet, in fact, sort of added a really very speculative idea, which his own data doesn't provide any evidence for, but he stuck to tenaciously throughout the rest of his life, which is that even if we lack free will, even if our conscious intention can't be the cause of the brain activity that precedes our action and can't be the cause thereby of our action, then you've got this 206 milliseconds after you feel the conscious urge to move and before you actually move, and that might be just enough time for free won't. So we don't have free will, but we might have free won't, and we might have some completely conscious capacity to perform what he called conscious veto. So this I think of as just a sort of a backdoor dualism to readmit the idea of conscious control of action, which if you're a physicalist neuroscientist, you shouldn't really believe in anyway. So this experiment generated an enormous amount of critique, and there's a particularly interesting Target article in 1985 by Libet where he was attacked by his contemporaries for various reasons. The instructions for the experiment are bizarre. The context in this is too thin. It's not really what we mean by voluntary action because the actions are meaningless. There's no reason to press the button at one moment rather than another. There's no motivation. It's true that the phenomenology, this feeling of the urge to move, is a strange piece of phenomenology. It's weak and it's unclear. And maybe there are lots of other problems with the way the readiness potential is recorded, that it's a biased way of sampling brain activity. So I'm going to leave those critiques and move on. It seems to me that Libet's results, that brain activity comes first and conscious experience comes second, are completely physicalist, but he somehow managed to nevertheless reach a dualistic conclusion. And it's interesting that Libet attended a series of meetings at the Vatican in the 60s and then again in the 70s and 80s. And they were coordinated by an extremely impressive Nobel Prize-winning neuroscientist called John Eccles. Libet at that time, this was the first of these meetings, it was in 1964, before I was even born, interestingly. And Libet wasn't talking about voluntary action. He was talking about some much more classical experiments on stimulating the sensory cortex of neurosurgical patients. But he met Eccles, and Eccles' dualism coupled perhaps with the idea of Donald Mackay, who was both a very brilliant cybernetic psychologist and a committed Christian, may have led him to think about the relationship between free will and consciousness and intentionality, which subsequently produced his subsequent 1983 paper. The immediate afterlife of the Libet experiment's been pretty active, and in philosophy, there's almost an industry of people working on this. The late Daniel Dennett, unfortunately now no longer with us, really made the importance of Libet's experiment available to the philosophical community as a whole. And he had introduced this idea of the Cartesian theater, which is a fake idea of how the mind works, suggesting that there's a little man in your head who is watching the stimuli that reach your retina. This is obviously rubbish. And his suggestion was that we should think about consciousness not as watching stimuli, but rather as the brain trying to integrate with a whole series of cuts and drafts and reattempts all of the different inputs that we receive to produce a conscious experience which is coherent, or some way that we can reinterpret and reorganize all of the inputs that we receive. The problem is that Dennett's model of consciousness is very perceptual. It's organized around understanding inputs. And when you think about voluntary action, there is no input. As I've said, voluntary action, all you have is a control signal. You have some signal in the brain, which is sent from the brain to the muscles. And this kind of model, which is based on the integration of inputs, doesn't work well when the key ontological commitment is the idea of a command or a control signal. So Dennett's theories work rather well with Libet's early work on sensory experience, which I don't have time to talk about today, but it doesn't work well with his idea of voluntary motor command. More recently, Stan Dehaene here in Paris has built a wonderful theory of consciousness called the global workspace, in which consciousness is conceived of as the transmission and amplification of a single representation across multiple brain networks. And this too is a fairly input-based and perceptual model of consciousness, because a single input gets broadcast to all of the different modules in the forebrain. So this idea suggests that consciousness should be very dominant. It's whatever is most salient within our cortex at the moment. But when we make voluntary actions, we're marginally aware of them. They can be very important, but they're often phenomenally very thin. We just get on with whatever we're trying to do with making actions. So again, the consciousness science doesn't quite capture what Libet, I think, really was telling us. Libet's work had enormous influence, and still does, in social psychology. And here we need to point to the work of, again, the sadly no longer with us, Daniel Wegner. And Daniel Wegner's work suggests that, agrees with Libet, that maybe brain activity, unconscious brain activity, causes our body movements. But maybe we know about our body movements by sensory feedback. So we post-dict or retrospectively confabulate a feeling of conscious intention, which we retro-insert into the stream of consciousness as if it was the cause of our action. So this dotted line here is just a kind of a psychological fiction. There is no real conscious intention, but our mind produces a narrative that there is. So Wegner's work is called The Mind's Best Trick, and our intentions, our volitions, our trying is just a trick. So conscious intention is not a real experience, and it in fact reflects post-dictive inference and reconstruction. And in this area of research, subtle social cues are often thought of as the real cause of people's voluntary actions. It's not that your action is really up to you, it's that you're somehow taking in social signals from your cultural and social environment, and they're nudging you somehow to produce actions which you then label to yourself as voluntary. So Libet's experiment has had a very interesting prehistory and a very interesting post-history, none of which quite deals with the question of how we can turn thoughts into contractions of muscles. And I'm going to read a rather texty slide just to end. So Libet's experiment seems to me like it's the high point of something that should have happened in the 19th century, which is this conflation of Enlightenment philosophy and physiological measurement, but it actually took a long time before it happened. Libet did a 19th century experiment, perhaps 50 to 100 years after one might have imagined it happened. But this was a novel attempt on a core question of mind and brain science. The fact that we have autonomy in our actions is still perhaps one of the hard problems of mind science. And Libet's results are basically what a physicalist neuroscientist might imagine, but I think his intuitions and his interpretations are surprisingly dualist, and he's ended up being criticized from both directions as a result. Almost all discussion of Libet comes from our dominant paradigms in neuroscience are really those of perception. We understand visual perception pretty well. We don't understand volition and will at all. So many of the critiques fail to recognize the important concept of a motor command signal. This is an idea which is popular in control engineering, but it's misunderstood, I think, in mind science. And Libet did understand that. Libet came from the neurophysiological tradition of working on human neurophysiology as a control engineering problem. So somehow that idea of what are these command signals has been lost in the discussion of the experiment. The intuition that conscious intention occurs when some buildup of preparatory activity reaches a threshold, I think is still a good idea. And maybe a scientific understanding of how volition and consciousness work becomes easier if you can decouple it from all of the very important philosophical and normative questions about how are we going to have notions of moral responsibility that can make our society work. Thank you very much for your attention.
Thank you so much. Right, we have some time for questions. Yes, Sadi.
Hi, Sadi. Hi.
Oh, thank you. Can you hear me? Thank you.
Yes, yeah.
Thank you very much, Patrick. I had just a very simple question, but when you're recording this voltage, right, in this rising before onset, right, is that only on the motor cortex, or is that something else? Because you could quite well think that the representation system is somewhere else, and then there's building, of course, of the activity, and then it reaches the motor cortex, which would make, there would be no paradox, and we could keep us kind of not dualist, but you see more classic interpretation.
Yeah, great question, and a really interesting one. So we align the recording to the moment when the person makes the action, and the earlier before that we look, the less confident we should be in our recordings because the signal to noise ratio is less favorable. But basically, having said that, there is a consensus that the earliest preparation of voluntary actions happens relatively anteriorly in the prefrontal cortex, and the readiness potential gets bigger in amplitude and moves anterior-posteriorly in its location as it follows a gradient from thought to action. So I'm being a bit simplistic, but there are many theories of prefrontal function which have this interesting concept of a cognitive hierarchy with more abstract thoughts in the more anterior parts of the frontal cortex and really, really concrete control of action. So representation of individual muscles in the motor cortex, which is at the sort of back of that little gradient. And that seems to me basically true. I mean, one of the interesting things about the human mind is that we can think and we can turn our thoughts into actions. And that corresponds to this sweep of activity and buildup of the readiness potential as it transfers from the frontopolar cortex to the motor cortex.
So do I understand that we're stuck to EEG because the problems of temporal resolution on other types of imagery? Because we could have a better resolution if we had something else, right?
Yeah, great point. I think the point is that these are causal questions. So these are questions about what's the cause of my action and what role, if any, does consciousness play in that causation. And really, time is pretty helpful if you're thinking about causation because of the general idea that causes really should precede their effects. So I think for that reason, the time resolve methods, EEG and MEG, have tended to be more helpful for experimental investigations of this area. People have done these experiments in fMRI and methods like that. Of course, the temporal resolution is worse, but the general idea that the prefrontal cortex is massively important for the initiation of voluntary actions, particularly voluntary actions which are sort of intelligent, which are solutions to problems, those sorts of interesting voluntary actions that really do something useful, those seem to massively depend on the whole hierarchy of prefrontal cortex. And the fMRI results clearly show that.
Thank you.
Great. We have Greti next.
Thank you very much, Patrick. This was the tour de force. You have taken up the most important and most difficult concept of psychology, consciousness and body-mind. And I'm sure you have already touched upon my questions here, more or less implicitly. About consciousness, I'm still not quite sure about the will parts of your talk. And thinking of, well, if we say that will is conscious deliberation, then we go back to Spence, who said that unwilled action is an oxymoron. Can there be unwilled, unconscious will? That's the real problem that you are actually dealing with. The other question is the mind-brain part of it. We now know that the body metabolic signals, the microbiota even, through the autonomic nervous system, influences decision-making. So it's complicated enough, but when you begin to take emotion into the picture, and not only cognition, and if you talk about emotion, you're also talking about the body, what does it look like?
Yes, very helpful questions. Thank you, Betty. So I think I'm going to try to deal with the second one first. So the phrase that comes up again and again when we think about voluntary actions is that they're internally generated. They're up to you. You're autonomous. There's something coming from within. And normally the way that that's operationalized in experiments is that we don't give people any stimuli to which they can respond. So we invite them to make an action, but there's no particular stimulus to say, go, do it now. And that raises the possibility that maybe voluntary actions are still triggered by a stimulus, but it's some internal stimulus from the internal milieu, for example, from the heart, or which is somehow driving or entraining or at least influencing when we choose to act. So people have looked for that. And in fact, I'm involved in a couple of projects where people are trying to see whether voluntary actions are always made during systole of the heart, of the cardiac cycle, those kinds of projects. And the effects tend to be pretty small. So I think it's difficult to produce a sort of a rigorous description, but I think one thing that happens when we ask people to make voluntary actions, which is in itself a bit of a paradox, and to instruct people to make voluntary actions is a bit weird. I think quite often what they do is they try to reconcile all the things that they are thinking about and that their mind is currently doing, and find a place within that stream of mental activity where a voluntary action can fit. What part the internal milieu and the body and emotion plays in that is not well understood, not easy to study in an experimental lab, and I think it's an area where we probably need a bit more research. I want to come back to your first question, which was about the sort of conscious part. So I think we don't really quite know sometimes what we mean by consciousness. We don't often define it very clearly, even when we do research projects on it. And our sort of, there are a couple of senses of consciousness which are clear. One, I think, is visual phenomenology. So I think colleagues who work in vision science they've got a fairly good idea of what it means to see something, and you can do experiments in the laboratory on conscious perception, or you can do them also outside the laboratory, because those of us who are lucky enough to see share a very rich range of phenomenal experiences of the visual world. But action isn't quite like that. The feeling of acting, or the feeling of deciding to act, or wanting to act, or trying to act, or being about to act, is nothing like the feeling of sensing or seeing or perceiving anything. It is a feeling. It is some sort of conscious state, in my view. I don't think it's just a fiction, as the social psychologists have suggested. But it's certainly nothing like visual awareness. And the second sense of consciousness, which is perhaps not as well defined, but probably also important, is really the sense of self. So quite often people talk about consciousness when they mean self-consciousness. So what's it like to be you? And sort of a much more general event-independent sense of having a mind that continues through time and produces a coherent subjective experience. And again, that seems to be relatively independent of individual acts of will. So the words conscious free will often go together as a trilogy, but maybe it's easier just to ask whether the will is free and not worry whether it's conscious or not. Or maybe it's more useful to ask whether there is a conscious will and not worry whether it's free or not. So actually, from an experimental point of view, it's easier to pick one of those two adjectives, either the conscious will or the free will, and not worry too much about the conjunction of both of them.
Brilliant. Thank you very much.
Great. We have a couple of minutes left. So next is Daniel.
Thank you very much, Patrick. I really enjoyed that, and I really enjoyed the connection from the sort of modern details of the Libet experiment back to this triplet of cognition, emotion, and conation. I wondered, though, how much you thought, given the sketch of what's actually happening in the Libet experiment, you think it is a study of conation, or it's a study of cognition. It's a study of your awareness. It's a kind of cognition or a perception about some of these ongoing processes. And does that mean that actually this chronometric approach has still struggled to really give us a way of looking at conation? It's still a cognition about conation.
Yeah. Great question. So, I mean, the real problem with the Libet experiment comes from this bizarre instruction: please press the button when you feel like it. So this is paradoxical. And as I think one of my schematic slides briefly showed, the real problem with the psychology of voluntary action is that if most good experimental method is based on treating the thing you're studying as a black box, manipulating the input and measuring the output. It's what our colleagues in engineering call system identification. It works really well. It's a great way to understand things, but you have to be able to manipulate the input. And the concept of voluntary action is that the input's up to you. So the Libet experiment is perhaps a bit of a fake, in the sense that if I say, please make a voluntary action when you feel like it, maybe this instruction or the social situation is somehow proxying for a genuinely autonomous action. And people have done some quite good experiments recently trying to get reasoned voluntary actions into the laboratory. So trying to produce laboratory situations where the action is up to you, but there's a reason why you make the particular action that you happen to make. And at that point, you've got something which is more like a genuine conation. You've got something you want to do. You've got a goal. You've got what the German early psychologists called determinierende Tendenz, which doesn't translate well, but this sort of teleology, this idea that I want to do X, that you're striving for X. Really, I think you can do clean, rigorous, controlled experiments which miss this pull of desire, or you can try and deal with the realities of human desire and accept that your experiment's going to be a bit messy. I think we need both. I think one of the things that's problematic in this area is that we don't have a broad range of methods which are all focalizing on the same thing.
Very helpful, thank you.
Great. And Enrique.
Try to make the question short because I believe the next speaker is going to make a fantastic presentation.
I'm waiting, yeah.
So thank you for this great presentation. You know that there is in behavioral economics, particularly also in experimental psychology, a very strong tradition, and you mentioned this tradition, analyzing reaction times. And basically in behavioral economics, what we do is to say, well, this is very context dependent. Depending on the setting, the decision setting, you tend to make decisions faster or slower. And also depending on your type, you may use system 1 making an intuitive decision or system 2, whatever. So from your presentation, I have the feeling that we are missing something here. That reaction time is only considering one fraction of the problem, that we may find that we start thinking about making a decision at different times, depending on the settings, and that we, of different types, also may start thinking about making decisions earlier or later, depending on maybe, I don't know, who we are, our type in game theory terms. I don't know if this makes sense to me, but it seems that the literature you presented today, and of which I was roughly ignorant, well, it's really an opportunity to rethink this branch of the literature.
Yeah, thank you. It's a very good question. I think one of the things that these sorts of experiments just a minute. One of the things that these kinds of experiments clearly miss is the fact that we sometimes make a decision for much, much later implementation. So, you know, you might decide that you want to become a professor. Now, nothing is going to happen for decades, right? So what we can study in the laboratory is these very proximal decisions, which are associated with immediate movement. And this kind of method is a little challenged by sort of long-term, what is called in psychology, prospective memory. I must, you know, I need to do something which will actually happen a long time later. So we can talk about that maybe offline. I think the attempt to give people a reason to press the button is the first step to getting better ideas about this way that our actions represent the end of a potentially rather long chain of thought. You mentioned individual differences, so I'm always a little bit worried about individual differences. My style in psychology perhaps is to look at the things that we mostly share rather than the things which differentiate us. I'm not aware of good experiments on individual differences in consciousness of intention. If you look at social systems like the law is based on a concept of mens rea, which basically says, you know what you're doing, your action is the product of conscious intention, and that's why we're going to hold you responsible. Now, if you know, some people had conscious intentions long before, and maybe some people after they'd actually pressed the button, then I think the judges would have a very stressful time trying to dealing with lots of people saying, oh, I didn't experience it that way when I pulled the trigger. So I think the basic way that we experience our own actions and our own bodily movements is relatively consistent. And I think this idea that we know what we're doing as we do it is a really quite common feature of the voluntary motor system. And I think that's the reason why we can have a society based on mens rea.
Thank you.
Great. So that's all the time we have for this first talk. Thank you so much, Patrick, for your talk. Thank you so much, everyone, for the questions and for attending.